For the first time in human history, we know the exact half second the moon gets hit, and this time the whole world can watch. Today is July 30th, 2026, and 6 days from now, a derelict rocket the size of a 5-story building strikes the lunar surface with the energy of roughly 3 tons of TNT. The only other predicted impact in history hit the far side, hidden from every telescope on Earth. This one hits the visible edge where hundreds of tons of moon dust could rise into black sky. Here's when it happens, why nothing can stop it, and how to watch it for yourself. 6 days from today, at 34 minutes and 32, 9 seconds past 6 in the morning Universal Time, on August 5th, a 5-story piece of rocket hardware slams into the moon at roughly 400 miles per hour. That is not a forecast with error bars measured in days. The most recent formal solution, updated on July 17th, is good to within a few seconds in time and a few kilometers in position. In the final days before impact, additional tracking is expected to tighten those numbers down to tens of meters in a fraction of a second. Either way, this is one of the most precise appointments in the history of spaceflight, and the appointment cannot be moved. Think about what that precision actually means. Weather forecasters cannot tell you within half a day when a hurricane makes landfall. Earthquake scientists cannot give you a date at all. But for this event, a collision between a tumbling dead rocket and the moon, astronomers have published a time stamped to the 10th of a second, nearly a year in advance. The prediction has been public since September of last year. Humanity has been watching this one coming for almost 11 months, refining the appointment with every new observation, and the appointment has held. For viewers in North America, the timing translates to roughly 2:34 in the morning Eastern Time on Wednesday, August 5th, which is about 11:34 Tuesday night on the West Coast. The target is the moon's near side at 19, 4 from 55 degrees north latitude, 93, 594 degrees west longitude, near a crater named Einstein, in old, heavily cratered terrain almost exactly on the moon's western edge as seen from Earth. That location matters more than any other detail in this story, and here's why. The last time a piece of human-made junk was predicted to hit the moon, it struck the far side, completely out of view. This one hits where telescopes can actually point. No one alive, no one in history, has ever watched a predicted human-made object strike the moon. Next week is the first scheduled chance anyone has ever had. And the strangest part of the story is not the collision itself. It's that the entire apparatus of human spaceflight, every agency, every tracking network, every mission control room on Earth, can do nothing about it except watch. To understand why, you need to know what this object is and how it spent the last year and a half. The object carries the catalog designation 2025-010D. It is the second stage of a SpaceX Falcon 9 rocket that launched on January 15th, 2025, carrying 2 commercial moon landers at once. One of them, Firefly Aerospace's Blue Ghost, touched down successfully on March 2nd, 2025, the first fully successful commercial lunar landing in history. The other, a lander from the Japanese company iSpace named Resilience, went silent about 90 seconds before touchdown that June and crashed. The rocket stage that threw both of them toward the moon had no such destination. Its job done, it was left in an enormous lopsided orbit around Earth, swinging out as far as roughly 510,000 kilometers and back in to about 220,000, looping around once every 26 days. Here's the problem with that orbit. The moon circles Earth at an average distance of about 385,000 kilometers. The rocket's path crosses that distance twice on every lap. For over a year, the stage and the moon kept missing each other. Close pass after close pass, nothing more. This is worth pausing on. The collision was never inevitable. Multiple near misses came and went, and each one slightly reshaped the orbit. What finally locked the rocket onto the moon was not a malfunction or a maneuver. It was sunlight, the same faint, constant push that complicates the tracking, slowly nudging a dead machine toward a world it was never meant to touch. On August 5th, for the first time, the stage and the moon arrive at the crossing point at the same moment. The other 2 objects from that same launch met tidier ends, which sharpens the contrast. The payload canister that held the 2 landers together fell back and burned up over the southern tip of South America in March of 2025. The landers reached the moon on purpose. Only the rocket that delivered them was left with no plan at all, parked in an orbit nobody managed, on a path nobody owned. The stage itself is about 12 meters long and 4 meters wide, roughly the height of a 5-story building, and it is mostly hollow, empty aluminum lithium fuel tankage with a single Merlin vacuum engine bolted to one end. Its mass is estimated somewhere between roughly 4,000 and 4,900 kilograms, depending on which research team's estimate you use. It has no fuel, no power, no working thruster, and no radio. It has been dead hardware since January of 2025, and every meter of its path since then has been set by exactly 2 forces, gravity and sunlight. Now ask yourself, who discovered that this collision was coming? It was not NASA, It was not the Space Force. It was not any government tracking network anywhere on Earth. It was an independent astronomer named Bill Gray, who runs a project called Project Pluto, and whose orbit computation software flagged the impact back in September of last year while chewing through observations collected almost by accident. That deserves a moment because it exposes something most people don't know. Military radar catalogs low orbit debris down to lost astronaut gloves and dropped tool bags, but radar obeys a brutal rule called the inverse fourth power law. Push an object 400 times farther away, and its radar echo comes back tens of billions of times fainter. At lunar distances, the world's radar fences are effectively blind. The only instruments that see high-flying junk are asteroid surveys, telescopes hunting dangerous space rocks that occasionally catch a slow-moving point of light that turns out to be a discarded rocket, and a scattered community of amateur astronomers. Sit with that for a second. The asteroid surveys that flagged this rocket were not looking for it. To them, high-flying junk is a nuisance, false positives contaminating a search for objects that could actually kill people. The discovery of a moon impact nearly a year in advance was, in effect, a byproduct of someone else's telescope time, noticed by one man running orbit software that no agency commissioned. That patchwork community is what tracked this object. By this summer, well over 1,000 observations had piled up from observatories in Mississippi, Utah, Beijing, and England, plus surveys and backyard telescopes. One British observer captured a 12-minute exposure in which the tumbling stage brightened and faded 5 times. Another measured its light curve at a little over 3 minutes per cycle. Those tumble measurements are not trivia. They are the whole ballgame for the prediction because the one force nobody can compute perfectly is sunlight. Solar radiation pressure, the faint, constant push of light itself, keeps nudging the stage, and how hard it pushes depends on how the object tumbles. Gravity is known to extreme precision. The sunlight push is why an earlier update this summer moved the predicted impact point by roughly 170 kilometers to the northwest, and why the most recent update on July 17th moved it by only a couple of seconds and about 10 kilometers. The prediction is converging. The rock-solid appointment stands. So why can't anyone stop it? Not because of physics, but because of absence. There's no engine burn coming because the stage has no fuel. There's no command to send because it has no radio. And there is no rescue mission being scrambled because no such mission exists anywhere on this planet. No agency, no treaty, no office in any government has the assignment of managing dead rockets in the space between Earth and the moon. Gray himself has put it bluntly. Generally speaking, high-altitude junk goes ignored, except, it seems, by him. Let that stand as a plain fact because it is the honest center of the story. A civilization that can predict a collision nearly a year in advance to the half-second on a body it is actively planning to inhabit has no one whose job it is to know about such collisions, let alone prevent them. Nothing about August 5th can be stopped and nothing is trying. What can happen is science, and as it turns out, quite a lot of it. Start with the raw numbers of the impact itself. At about 43 kilometers per second, carrying up to roughly 4,900 kilograms, the stage hits with about 14. 5 billion joules of kinetic energy. That is the energy of roughly 3 tons of TNT, about 15,000 sticks of dynamite delivered to one point on the lunar surface in a fraction of a second. The stage will be moving at what would be Mach 7 in air, arriving at an angle of about 31 degrees above the local horizon. The expected result is a brand new crater somewhere between roughly 17 and 30 meters across, the lower estimate scaled from the last confirmed junk impact in 2022, the higher one from the team organizing next week's observing campaign. Both estimates agree the crater will be smaller than an asteroid of equal energy would dig, because the stage is a hollow shell, not a solid slug. The excavation, though, is real, on the order of several hundred cubic meters of lunar rock and soil, over 1,000 tons of material blasted outward with no atmosphere to slow a single grain of it. And this is where the impact turns from accident into asset. Every crater scientists have ever studied came from an impactor whose mass, speed, and angle had to be guessed after the fact. Next week's crater is different. The projectile's size, mass range, velocity, arrival angle, and arrival time are all known in advance, down to the fraction of a second. That makes the fresh scar near Einstein crater a calibration point for the crater, scaling laws scientists use everywhere, including the models behind planetary defense, the calculations that would tell us what a dangerous asteroid would actually do to a city. A dead rocket is about to hand that field a free ground truth experiment. The question that decides whether next week becomes a global spectacle or a quiet footnote is brutally simple. Will anyone actually see it happen? The answer splits into 2 very different pieces, a flash and a cloud. Here's the disappointing half. The impact flash itself, the split-second burst of light at the moment of contact, will almost certainly be invisible from Earth. The impact site is in full lunar daylight, and no impact flash has ever been convincingly detected against the moon's sunlit surface, not even by professional observatories. Worse, this impactor is slow by lunar standards. Natural meteoroids hit the moon at 10 kilometers per second and up, some well past 70, and the fraction of impact energy that becomes visible, light climbs steeply with speed. At 43 kilometers per second, this stage is a bottom-of-the-scale glow buried in daylight. The physics of that is simple and unforgiving. An impact flash is thermal light, vaporized rock and metal glowing for a fraction of a second, and impact heating scales with the square velocity. A meteoroid at 20 kilometers per second delivers nearly 70 times the energy per kilogram that this stage will. Astronomers routinely record those natural flashes, but only on the moon's night side against darkness. This impact stacks the deck the wrong way twice, a slow projectile on a sunlit surface. History agrees with that pessimism. In October of 2009, NASA ran this exact experiment on purpose. The L-Cross mission steered a spent Centaur upper stage into a crater near the lunar South Pole, timed the strike for favorable viewing conditions, and pointed large telescopes at the site. From Earth, they saw no visible flash. If a deliberate impact stage for ideal viewing conditions produced nothing visible, a dead rocket hitting a sunlit surface will not beat it. But the flash was never the real prize. The real prize is what comes up afterward. Because the impact point sits almost exactly on the moon's western limb, the visible edge, any dust thrown upward could appear from Earth, silhouetted against black sky, hugging the bright rim of the moon, lit by sunlight scattering through the grains. Not a flash on the surface, a cloud rising off the edge of another world. Research teams modeling the event have run the numbers on that cloud. Their simulations show an ejecta curtain climbing somewhere between 15 and 20 kilometers above the surface, with a central spike of fast debris potentially reaching 75 to 100 kilometers high, and material spreading roughly 183 kilometers outward from the impact point. In the first few minutes, the simulated cloud could outshine the dark sky background by several orders of magnitude, potentially lingering on the order of 10 minutes. That's the optimistic case. The honest case is a genuine open question, and the man who predicted the impact is himself the source of the caution. Gray's own back-of-envelope calculation assumes slower ejecta around 100 meters per second, which would rise only about 3 kilometers before falling back, separating from the moon's bright edge by a margin that's marginal for any telescope on Earth to resolve. The wild card is speed. If a meaningful fraction of the debris leaves at 300 meters per second instead, it climbs roughly 9 times higher and the event becomes unmistakable. The modelers say, watch. The predictor says, maybe. Nobody on Earth knows, and that is precisely what makes next Wednesday morning an experiment nearly a year in the making, with the whole planet invited to run it. There's even a chemical twist. The stage's tanks are an aluminum-lithium alloy, and observers are being encouraged to try a narrow filter tuned to the lithium emission line at 670, 8 nanometers. If that faint lithium glow shows up in the plume, it would be a first in history, the chemical fingerprint of a human-made impactor read directly from its own debris cloud, and a proof of concept for reading the composition of any impactor from the light of its ejecta. To understand what to expect next week, it helps to go back to the only precedent, March 4th, 2022, because that event calibrates everything about this one, and it left behind a mystery that August 5th might reopen. That was the first predicted lunar junk impact in history, also called by Bill Gray, not by any agency, and it began with an embarrassment. The object was initially identified as a Falcon 9 stage from a 2015 launch, then re-identified after independent observers matched its paint spectrum to Chinese rocket hardware as the upper stage from China's Chang'e 5T1 mission of 2014. China has never publicly acknowledged the impact. That stage hit the moon's far side near a crater called Hertzsprung, where no telescope on Earth could watch, which is exactly why next week is unprecedented. When NASA's Lunar Reconnaissance Orbiter found the site months later, it photographed something nobody predicted. A double crater, 2 overlapping pits, spanning roughly 30 meters in total. A double crater implies significant mass at both ends of the impacting object, mass that was never disclosed on any manifest. That anomaly has never been explained. A standard rocket stage is a hollow tube with one heavy engine at one end. Whatever else was mounted on that Chinese stage, no public document accounts for it. It remains one of the strangest unsolved details in the modern lunar record. Here's why that matters for August 5th. The Falcon 9 stage arriving next week carried its heavy engine at one end and nothing comparable at the other, so the prediction is a single crater, roughly 17 meters across. When the Lunar Reconnaissance Orbiter photographs the fresh scar near Einstein crater in the weeks after impact, that image becomes a verdict. 1 crater, and the physics closes cleanly. 2 craters, and the 2022 mystery reopens on an object we thought we understood completely, this time with over 1,000 observations of tracking data behind it. For anyone worried about the moon itself, it takes hits like this constantly. In the spring of 2024, a natural meteoroid gouged a crater roughly 225 meters across into the lunar surface, 10 times the diameter and roughly 1,000 times the energy of next week's impact, and no one on Earth noticed it happen in real time. Apollo mission planners deliberately crashed the upper stages of Apollo 13 through 17 into the moon as seismic experiments. And the seismometers left behind recorded the moon ringing like a bell. The moon will be fine. What's new next week isn't the wound. It's that this one is ours. We saw it coming, and for the first time, we get to watch. So the collision is harmless and scientifically useful, which brings back the question this story keeps circling. If we could see it coming for nearly a year, why does the answer to who's handling this keep coming up empty? The reason August 5th cannot be stopped is not engineering. It's that between Earth orbit and the moon lies a volume of space where surveillance is effectively blind, ownership is undefined, and cleanup is nobody's job. Roughly a dozen dead, high-flying objects are currently known to be wandering that region, known only because one contractor in a community of amateurs bothered to keep looking. More than 600 Falcon 9 rockets have launched. Most spent stages fall back into Earth's atmosphere or are thrown into orbit around the sun. This one simply wasn't, and once it wasn't, it belonged to no tracking system on Earth. Compare that to how seriously we take the space closer to home. Low Earth orbit has collision avoidance systems, conjunction warnings, debris catalogs updated daily, and international pressure on operators who leave junk behind. Cross an invisible altitude line, and all of it evaporates. The stage that hits the moon next week spent over a year in a region where the sum total of humanity's monitoring effort was one contractor's software, and whatever asteroid hunters happened to catch by accident. What makes that uncomfortable is that the fix exists and costs almost nothing. It's called heliocentric disposal, using the last breath of fuel to throw a spent stage into orbit around the sun, permanently out of Earth-Moon space. It was done for the stage that launched the James Webb Space Telescope. It has been done for other recent lunar missions as well. It is simply not required, and so it is not routine. Meanwhile, the traffic is multiplying. An era of renewed lunar exploration means more lunar launches, more discarded stages, more dead hardware crossing the paths of future landers, orbiters, and eventually crews. Every one of them will fly through the same untracked volume this rocket has wandered for the past year and a half. Next week's impact is a free warning shot, the gentlest possible demonstration of a blind spot that will not stay harmless forever. Before wrapping up, it's worth addressing claims circulating online that this impact is somehow deliberate, that the stage is being aimed at the moon, or that its identity is being hidden. The tracking data dismantles both claims in seconds. The stage has been unpowered for over a year. Steering requires propellant and a working engine it does not have. The predicted impact point drifted by well over 100 kilometers between updates earlier this summer pushed by nothing but sunlight. Nothing aimed behaves that way. As for identity, the 2022 mix-up gets cited as precedent for a cover-up, but it actually proves the opposite. That misidentification was caught and corrected in public by independent observers using the object's own paint spectrum. This object is anchored to its January 2025 launch by well over 1,000 observations. The record is open. The physics is boring. The truth is stranger than the conspiracy, and nobody aimed this rocket at the moon because nobody was capable of aiming it anywhere at all. So here's what happens next, and how to see it for yourself. Between now and August 5th, tracking updates will pin the impact down to within a few dozen meters in a fraction of a second. There is one genuine wildcard left, a small chance that the refined impact point slides slightly, and because the site sits right on the visible edge of the moon, a shift in the wrong direction could push it over the limb to the far side, hiding the entire event. Every update between now and next Wednesday matters. If it stays on the near side, the viewing geometry favors this hemisphere specifically. The eastern half of North America and much of South America get the best seats. The moon will be roughly half illuminated in a dark sky at impact time, rising around midnight to 1 a.m. local time in the eastern United States, with Saturn conveniently nearby as a signpost. The advice from the observing campaign organizing coverage of the event is that you don't need an observatory. Backyard-class telescopes may be enough. Frame your shot so the moon's bright disk sits just off the edge of the camera sensor. Kill the glare and record at 20 frames per second or faster. An infrared filter helps cut the daylit disk's brightness, and if you want to attempt the historic measurement, that lithium line at 670.8 nanometers is the target. A dry rehearsal the night before, when the moon sits at nearly the same phase and position, is recommended for anyone attempting to capture it. Then, in the weeks after, watch for the Lunar Reconnaissance Orbiter's photograph of the fresh crater near Einstein. The image that either closes the file with one clean scar or reopens the 2022 double crater mystery all over again. Either way, next Wednesday morning, humanity keeps an appointment it made by accident and confirmed to the fraction of a second, the first predicted human-made impact on the moon that anyone alive has ever had the chance to actually watch happen. Whether the dust rises high enough to see or the moon swallows the moment in silence, the answer arrives at 34 minutes past 6 Universal Time, 6 days from today. Watch the limb. There's also a quieter experiment riding along with this event that deserves mention, because it points toward why this impact matters beyond a single night of observation. The teams organizing the observing campaign are explicitly using August 5th to test a pipeline for pinpointing lunar impacts from Earth-based observations alone, a direct descendant of the Apollo-era work when those deliberately crashed rocket stages calibrated the seismometers astronauts had left behind on the surface. If the localization technique works cleanly on an impact whose time and location are already known to the fraction of a second, it becomes a validated tool for future lunar seismic networks trying to pin down the location of unknown, naturally occurring impacts elsewhere on the moon. Success or failure on the observational side, the data from this event flows somewhere scientifically useful either way, which is part of why researchers across multiple institutions have spent months preparing for what is, at its core, an accident nobody engineered and nobody can prevent.